We are the Gearheads, and we are Cal State LA mechanical engineering students currently enrolled in Professor Davidian's ME 103 class, fall 2015. I'm the group leader, Brandon Kawaguchi.
I'm Ramon Gabuzian.
I'm Tron Hernandez.
And we will be presenting our final project, which happens to be a beta-type Stirling engine, which uses one cylinder. Inside is a loosely fitted displacer, which moves hot air from the bottom to the top, providing power to our diaphragm, which then provides power to our crank.
This cycle mostly takes place in the aluminum can, which divides into two chambers, the heating part and the cooling part. This chamber is being done by the displacer, which in this case we use a steel wool due to its lightness. The other portion of this part is the elastic balloon, which will act as a driving force in order to push the cold air back down. This is then attached to a bottle cap in order to provide greater surface area, make it easier to connect the two rods.
Over here we have our two rods, which are supported basically by the connection between the crankshaft and the displacer. As the displacer moves in the engine up and down, it gives motion to the crankshaft, which drives the flywheel into motion, which acts as the force for our engine.
As for the Stirling cycle itself, air is slowly heated up in the lower portion. This air eventually makes its way up and builds up pressure. This pressure then moves the diaphragm, which creates that rotating movement on the crankshaft. This crankshaft then rotates the flywheel. This flywheel creates a further driving force back into the elastic material, which pushes the cold air down into the heating portion, which restarts the cycle.
As our heat source is removed, our engine will begin to slow down in order for it to go back to room temperature. And this is countered by putting the heat source back, which then the engine will go back to its original heat and continue the cycle it was on before.